Hi guys, welcome to another video. So in this video I wanted to talk about the triangle inequality and what it actually means and how to intuitively understand it. So I'm not going to go through a formal algebraic proof, and there are actually other interesting methods of proving this, also by drawing parallelograms on graphs, but from what I've learned I feel like this is the most intuitive method, so that's what I'm going to show. So I'm sure you already know triangle inequality, which states that when we have three sides of a triangle, ABC, then A plus B must be greater than C, where C is the largest or longest side. Okay, now this might not be immediately obvious why this is true, which is why I'm gonna show an example using toothpicks. So here I have my three toothpicks, and what we're gonna do with them is we're gonna make a triangle and see why this is true. So before we get to that, first I'm gonna break these toothpicks into different sizes so that we don't have an equilateral triangle or an isosceles triangle. Let's say this is going to be our longest side. Then on this one I'm going to only break off a little bit. And on this one I'm going to break off a bit more. So as you can see, we have these three toothpicks, which are all different sizes, and we're going to make a triangle out of it. So why does this inequality hold true? Well, let's try to find out. So here I've made our triangle, just a normal triangle. And now let's see what happens if I push down on the top here. Now, the sticks aren't exactly holding together. I rolled right there. But yeah, as you can see, these two sides, which are both individually shorter than the longest side, if I push them down, they make a triangle they make a length which is longer than the longest one. So that shows the inequality being true. And then we can also look at this from another angle. Let's try to make a triangle where the inequality isn't true. So let's say that this is our longest side. This is our longest side. And then we're going to have these two other sticks that we just used before. But now we're going to break off another part just to make it obvious that the two other sides are just a little bit shorter than the longest side. I don't know if you can see, but there's a little bit of an interval there, so they're not exactly the same size. And if you add together these two shorter sides, they're shorter. The sum of their lengths is shorter than the longest side. So let's try to make a triangle out of this, and let's see what we get. Okay, well, that doesn't work. Clearly, if I try to augment the angle of this side, that's not going to get it any closer to our goal. And if I try to make it smaller, it's just not going to reach. So I hope that makes sense. And I will go over an algebraic proof or a graphical proof of this later on, but I feel like just intuitively, visually, that's a nice way to understand it. Thanks for watching.